Alright, so here's a video for 6.4. We learned about scatter plot and trend lines. Now this trend lines, we also call it very often in statistics, we call it line of best fit. Okay? This line of best fit is pretty much exactly what it says. We want to draw a line that best fits our data points. So scatter plot is a graph. Okay, so scatter plot here, the definition we talked about in class, is a graph that shows the, let me lift it over here, is a graph that shows the relationship between two quantities. So I have a graph that shows the relationship between two quantities. We're always going to be dealing with two quantities, and we want to see a relationship between these two quantities. Anytime you have two things and there's a relationship between them, we call it a correlation, like co-workers, co-owners. So it's going to be called, we're going to be using the definition, the term correlation. So there's a relationship between two quantities. We want to draw a graph that shows this relationship, which is a correlation. And we also want to draw a line that is going to best fit this relationship, this data points, okay? And correlation, you could have two quantities that have a positive correlation, increasing in values as x is increasing, the y is increasing. You could have two quantities that has a negative correlation. So as x is increasing, the y is decreasing. So we're going to see all this kind of drawings here. And we could also have two quantities that does not have a relationship at all. They do not correlate. So that would be no correlation. And we always want to draw a line that best fit this correlation, this scatter plot, okay? So let's go ahead and take a look at your homework. After we talked about this, we talked about positive correlation, negative correlation, no correlation. We also talked about a correlation coefficient. So let me go ahead and keep writing here on our little brief summary notes. Every correlation has a correlation coefficient. We call that R. Okay, and R is a value that shows how strong the line that we predicted, this best line we tried to draw, it predicts how strong this model is, this correlation is. And R is a number between positive 1, 0, and negative 1. Okay, so R is a number between negative 1 and positive 1. Any value in between. The closer the number R is to a negative 1, the stronger it is a negative correlation. The closer the number R is to 0, it shows no correlation. And the closer that the number R is to a positive 1, the stronger positive correlation your model, our line of best fit, will have. So this number is always going to be given to us. We don't have to calculate. We just have to know that what matches, that this number matches with what kind of scatter plot and what kind of correlation this number is representing. So that's kind of like in a nutshell what we discussed in class and we took notes. Let's jump straight into your homework here, keeping in mind these ideas right here, okay? So over here we have worksheet 6.4 and they're giving us a table of values. Let's read what these numbers are representing. In statistics, the number speaks for itself. There are labels. Labels are important. So tickets sold, okay? And it looks like adult tickets and children tickets. So when I go to the movies, I take my kids. Sometimes I don't. So is there a relationship that for every adult ticket that's sold, they sell a certain amount of children tickets? That's what I read when I just look at the table. I'm not even thinking about what they're asking me. I'm just trying to understand what these numbers are representing. So for every 10 adult tickets, 30 children tickets are sold. And then 20 adult tickets, 55 children tickets. So it's interesting to see if there is a relationship between adult tickets and children tickets. Now, it's important to remember that in scatter plot, whenever we're dealing with statistics, You can check to see if there is a pattern. Okay, from 30 to 55, I would add 25. But then from 55 to 80, 25 doesn't work anymore. So there is not a consistent ratio of how it's increasing here, like we did with linear equations. So don't think that you can continue with a pattern, because that is not going to work. Okay, there is no pattern here. Those are just data points. Those are values that were gathered, and does not follow a specific pattern. All I can do here is to create a scatter plot with the information that is given to me. So they gave me the number 10, 30. If it helps you, you may create a vertical table if you want to. I am going to call the adult tickets my X values. So I'm going to put it in the X axis over here. I'm going to call it adult tickets. And I'm going to call my children tickets, the children tickets, I'm going to call the Y value. I'm going to put it in the Y axis. So I'm going to label over here children tickets. If you want to rewrite the table, sorry, that was a very crooked line. If you want to rewrite the table as X and Y's, you can. I would not waste my time doing it, but you can. So this is just to understand that the 10 tickets for adults goes with 30 tickets for children. 20 tickets for adults goes with 55 for children, and so forth. I'm going to put dot, dot, dot. I will not waste my time doing this, because I can read the table in a horizontal fashion just the same way as I can read it as vertically. But I want you to think that these are coordinates. 10 tickets for adults goes with 30 tickets for children. Okay, just like you would think of a coordinate pair. Okay. So I'm going to label my x-axis adult. I did it right there. I'm going to go by, let me see if it fits, 5, 10, 15, 20, 30, 25, 30, 35, 40, 45, 50. It works. I'm going to go by 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. I want to make sure that I can go from 10 all the way to 50, because that's what my adult tickets are. And I'm going to try the best I can to match in a very lined fashion way. It makes it a lot easier if you have a graphing paper. Okay, I don't have it here, but I want to do it on the paper that you would be doing your same homework. But if I had a choice, anytime I'm dealing with graphs, I would do it in the graphing paper, so I can have the most accurate grid underneath it. So I'm going to match 10 with 30. Here's 10. And here's 30. I made my y-axis here, which is the children axis, I made it by 10. So 10, 20, 30, 40, 50, 60, because I knew I needed to go as low as 30 and as high as 137. So I needed to go all the way to 140. Okay? So let me zoom in a little bit more, and then we'll zoom out in a little bit. But here we go. It is not going to be perfect, and I warned you in class, this is not going to be a perfect graph because we're doing it by hand. But here we go. I want to match 10 with 30. So 10 and 30. And I'm going to put a dot for 10, 30 right there. And then 20, 55. 20, that's 30, 40, 55 would be somewhere there in the middle. Let's see if that works for me right there. Okay? And then we need to match 30 with 80. So 30, and here is 60, 70, 80. Let's see if we can follow this little line here and here. All right, there we go. It is not going to be perfect, but we'll do the best we can. And then I'm matching 40 with 112. Here's 40. Here's 90. This is a 90, by the way. 90. This is 40. 90, 100, 110, a little bit above 110, and then let me bring it here and here, all right? Right there. And then we have 50, so here's 50, let me go as high as I can here. I'm matching with 137. This is 120, 130, not quite as high, and somewhere right there. Okay. Now, of course, if I had a grid underneath, it would look so much more aligned, and I would not have this kind of like, not perfect version of the dots here. Now, the dots are not going to be on the perfect line. I wish that if it wasn't a perfect line, that means we would have a pattern. But we don't have a pattern. We know it's kind of scattered around, but that's the best thing we can do here without a graphing paper. So there we go. I created my scatter plot, which was just matching the values 10 with 30, 20 with 55, and so forth. So they asked me, draw the line of best fit for this data. So the line of best fit, it's kind of a confusing matter here because we think, oh, I need to put above and below. What we want to do is to put the best possible line that will fit the most amount of points. I got to catch as many points as I can, but of course I'm going to have to leave some out. Okay, there's no way I'm going to get all the points. If I try to connect these 2 points right here, which was 10, the 10 and the 20, I'm going to leave some of them below. If I try to only do this second 2 points over here, the 20 and the 30, I'm going to leave this 50 way out. I'm not going to touch this 40 either. So I'm trying to find in between so I can catch as many as I can. Some of them is going to be above, some of them are going to be below, but that's okay. And if you actually have a grid and you did it better than me, I'm pretty sure your line is not going to touch every single thing there, okay? So there you go, all right? So as you can see here, it looks like I did not quite catch my 50, 137, and probably my 40 is a little bit below the line. Maybe I caught the 30, 80. So it is okay. We're trying to get the best line that fits the points. Some of them will be above, some of them will be below. We're trying to get the least amount of distance from the points to the line as possible, okay? So that is my line of best fit. I drew the best I could. It is going to get better when we have a graphing device. That's when you get the most accurate line. But here, we're just trying to do the best we can. That's why it's called the line that best fits the data. And since we're doing it by hand, it will not be perfect. Now, we want to write an equation for the line of best fit. So it depends what points you pick. The equation we want to use to represent a line is going to be the y equals mx plus b. That is one of the simplest, okay? You may also use the point slope form, which is y minus y1 equals m, which is the slope, and x minus x1. Either way is fine with me. In this one, all you need is the slope and one of the points. In this one, all I need is the slope and the y-intercept. So my line, I'm not sure what the y-intercept is. Some students want to try to guess. It's 0, it's 10. I don't know. Maybe my line should have been a little bit more steep. Maybe my line should have been a little bit more in this manner right here, okay? I'm just going to put another option. Maybe my line should have been more like this. We don't know, okay? So we just did the best we could with the line. I'm going to create an equation for the line I drew, okay? I don't know if that is the correct line, but I'm going to write an equation for the line I drew. So I need the slope. So that means I'm going to have to use the slope formula, which is y2 minus y1 over x2 minus x1. When I look at the slope formula, it tells me I need 2 y's and 2 x's, x values. So that means I need 2 points. I am going to pick 2 points that are easy for me to calculate. Some of you in class chose to pick the 10, 30 and the 20, 55. Some of you chose to do 20, 55 and the 30, 80. Everyone that picks a different point is going to get a different line, a slightly different equation, because your points are not quite on the line. So I'm going to pick the point 30, 80, and I'm going to pick 40, 12. I'm sorry, 40, 112. That's the 2 points I'm going to pick, okay? Because when you only pick 2 points, you're only picking the best line that fits those 2 points. So of course, if you only pick the first 2, you're trying to find a line that best fits those 2 points. It will be different than someone that picked the second 2 points. That means you're only going to get a slope between those 2 points. So each slope is going to be different according to the points you pick. That's why I asked you, please pick the same points as me so we can check that we're doing the work the same way and we're getting the same answer. I'm going to go with 30, 80 and 40, 112. All right, so I'm going to find the slope. This is going to be my x1. This is going to be my y1. The second point is going to be my x2 and my y2. And I'm just going to plug in the equation. My y2 is 112 minus my y1 is 80 divided by my x2 is 40 minus my x1, which is 30. And that equals 112 minus 80 is 32 divided by 40 minus 30 is just 10. In your calculator, you can see that 32 divided by 10 is just 3.2. So now we know our slope. I'm going to write right here, m equals 3.2. I already have that. Okay? So if you're using this equation right here for a line, all you need is the slope, which you have is 3.2, and you replace x1 and y1 right here with one of these points right here. And you're done. You created the equation. I want to do the y equals mx plus b. So that means I need to solve for b. Because I have the m, I don't have the b. And what we replace in the y equals mx plus b is we replace the slope, which we have it, and we need to replace the y-intercept, which we need to calculate. Do not try to guess the y-intercept because we don't know for sure, especially because we're only picking 2 points. So we don't know for sure, we need to calculate it. We'll calculate using one of the points that we already picked. So stay consistent here. So I know right now that if I was to write the equation of my line, would be y equals 3.2 for the slope times x plus I'm trying to figure out what b is. I don't know what it is, we're trying to figure it out. So all I have to do is pick one point to plug in for x and y in here, and the only thing that would be not a number would be the letter b. So if I pick 30, 80 and plug in for x and y, I would plug in 80 for my y, that would be 80, equals 3.2 times the x value is going to be the x value of the coordinate I'm choosing. So it would be 30 plus b. So now I have all numbers, and it's easy when all you have is all numbers to solve for that letter variable that we don't know what it is. 3.2 times 30, if you do it in your calculator, 3.2 times 30, you get 96. Plus the b value, we want to know what it is, and here we have the 80. If you subtract 96, so you can get b all alone, minus 96, you get that b is all alone equals negative 16. And there is your b value. Now you have your slope, now you have your b value. Now you can go ahead and write the equation, and I'm going to write it in green. Y equals, y always stays the same. The 3.2 is the slope that we figured it out, times the x, we leave it alone, plus the, it's minus 16, which is my b value. And that is the equation of that line that we drew with only 2 points, which was the 30, 40, 30, 80, and the 40, 112. So it's a line that goes through these 2 points right here to the best we could. So this x value over here represents adult tickets, okay, because that's the x-axis where we put it. And the y value represents the children tickets. You need to remember what the x and the y's represent, especially here in the beginning. I said let the x be the adult tickets and the y be the children tickets. So in my equation, I can plug in any adult ticket value, and I can make a prediction of how many children tickets I will sell according to how many adult tickets I plug in here. And that is the whole reason why we create a line. This line over here that we drew, it was based on the dots that were here, the points, but I can make predictions above 50 tickets for adults. I can guess, make a prediction. I wonder how many children tickets I would sell if I sold 100 adult tickets, okay, further down the line. So you can make predictions in this based on the equation of this line. Now let's answer one more question. It says, does the data show a positive or a negative correlation? Positive correlation, the line or the dots are in increasing manner. So as you can see here, 10 with 30, and then 20 with 55, and it keeps on increasing and increasing and increasing. So each x value is increasing, the y value is increasing as well. So it is pointing towards an increasing slope here, an increasing rate. So we say that this is a positive correlation. A positive correlation. If those dots were scattered coming down, we would say it was a negative correlation. But the dots are starting to increase as we are moving up over here. Okay, at least the ones that were given to us are increasing in values. And you can even see it from the table. 10 with 30, then 20 with 55, which is way higher than 30. Then 30 with 80, which is higher than 55 and 30. So you can see that the y values are increasing as the x values are increasing. So they're both increasing. It's a positive. Okay, so I'll write right here, the x values were increasing and the y values were increasing, also going upwards, and that's why it's a positive. We already can tell that it's a positive correlation. Now it says, if 60 adults bought tickets, how many children tickets would you expect to sell? And that's what we're going to be making a prediction. I have an equation, I have a model here. Y equals 3.2 times x minus 16. So I can actually make a prediction. You tell me how many adult tickets you sold, I can predict how many children tickets will be sold. Okay? So y is going to be how many children tickets, 3.2 times, I want to make a prediction, I want to expect to sell how many children tickets based on 60 adult tickets. So let's put 60 here, 60, and then you have to subtract 16 when we're done. So when you multiply this, 3.2 times 60, y equals 3.2 times 60. Let's see what we have here. 3.2 times 60, we get 192. So this multiplication is 192 minus 16, and when you finish it, you get 176 children tickets. Because that is what y represents. So you can expect to sell 176 children's tickets if you sold 60 adult tickets. Okay? And that's what the scatter plot does for us. We have some data points and we can make prediction for other values later on. We try to do the best line we can. Some of the dots will be above, some of them will be below. We're trying to fit the best we can, trying to catch as many points in, through our line. So that's what we did in class yesterday. Everyone should have finished this homework because we did this whole entire worksheet in class yesterday. Now, I'll let you try to do your own thinking. I would like for you to use your own thinking here. During 1 month, a local deli, the amount of ham sold decreased. So ham decreased as the amount of turkey increased. You try to choose which one you want to put in the x-axis, which one you try to put in the y-axis, so you can see that correlation and try to figure this one out. Do it both ways to see what happens. What happens if I put ham on the y-axis and turkey on the x-axis and try to create this idea as ham decreases, the turkey increased. Try to do the opposite way, as turkey is increasing and the ham is decreasing. See if you get the same graph, okay, based on the same story. As T is high, H is low. Or as H is low, T is high. Turkey sold increase. So higher turkeys, low ham. So see what you get there, okay? But there's an order here. They said the amount of sold of ham decreased as the amount of turkey increased. So play with it and let's discuss it. We also talk about the difference between correlation and causation. Correlation is just a relationship between two quantities. Is a relationship between two quantities. Now, causation is when one quantity causes an effect in another quantity. Okay, so it causes an effect in the other quantity. So let's talk about the cost of family vacation and the size of their home. So if you have a really expensive family vacation, is there a relationship, is there some sort of correlation between the expense, how expensive the family vacation was, and the size of the house? Usually, if you can afford to take a very expensive family vacation to the Caribbean, to exotic countries, you probably own a big home. So there is a correlation. I would say that there is a correlation, a possible correlation, but taking a expensive family vacation does not cause to own a big home. So I would say a correlation with no causation. Okay, it does not cause. Having a expensive family vacation does not affect, does not cause a person to own a big home. Okay. Now I will let you think through this too over here. Let's take a look at this one over here. A person's height and the number of letters in that person's name. Do you think that if you were to survey and walk around and asking a person's height and how many letters are in the name, do you think there would be any correlation, any relationship at all between those two quantities, height and a person's name, how many letters in a person's name? I feel like mathematically this would be no correlation at all. Okay, a person's height and how many letters are in that person's name, there's no correlation at all. I feel that there is a correlation when you exercise and how much calorie you burn. I think there's a correlation there because I exercise every day, and when I finish I check how many calories I burned, and that was an effect there. And as a matter of fact, exercise caused me to burn calories. So I think there is a correlation with causation, but here there's no correlation at all. Nor causation. Okay, there's no correlation and no causation at all. Okay? All right. The last thing we want to talk about to conclude this video before it becomes a half-an-hour video is just that value I told you about R. The closest the value of R to a +1, then we have a positive correlation. The closer it is to a -1, we have a negative correlation. The closer it is to 0, we have a 0 correlation, no correlation. Taking a look at these dots over here, all these little dots, the 2 matches with a 3. I can tell reading some of the numbers here. Looks like the 4.5 matches with a 3 and something. It's hard to tell, but let me zoom in a little bit more. Okay? So this scatter plot here is much nicer than the one I drew in the front, okay? And this is what I was talking about. If I was, let me just go on a side note here for a second. If I was to draw the line of best fit for this, I could not just try to match 2 little points. Or, here's almost 3 points. And, some kids try to get as many points as possible. I'm trying to get as little distance between all the points and the line I want to draw. So if I was to draw a line, they're not asking us to do that, but if I was to draw a line, I would try to draw it somewhere in between, so the distance between the points and the line of all of them would be as little as possible. So I would draw something like in between this point right here and this point right here, so I can get the least amount of distance between them as possible. Look at the distance from this to this, and this point to the line. This one is almost on the line. This one is almost on the line. I want to try to make this distance as little as possible. That is my goal, okay? That's what it should be, your goal. Let me find a line where the distance to the points are as little as possible. As you can see here, this line is a going up line. Okay, it looks like as the x values here are increasing, we get higher values of y. Okay, 8 is matching with a 9, and so I would call this a positive correlation. That means I want an R that is closest to the number 1. Let me go ahead and eliminate the negatives because it is not a negative correlation. So I'm going to eliminate this negative values. And then between 0.08 and 0.8, I believe that 0.8 is the closest to number 1 as possible. And that's how you're going to be playing with this. Take a look over here. I'm not going to do this one, but you see that's kind of, the points here are low x's and high y's. So x's are low, but y's are high. Number 1 goes with 7. Let me pick a 6.5, let's go like 5 and something over here goes with a lower value. And then even 8 goes with even lower value. So as x is increasing, sorry, I made this wrong. Okay, as the x values increases, the y values, no, let me make sure, let me do it again. As the x values increase, as the x values increases, the y values are decreasing. There we go. Okay, because I have a high value of x matching with a low value of y. So this would be a negative correlation. Okay, if I was to draw a line, I would try to draw a line right in between some of the points, trying to make them as close distance here to the line as possible. So you would have a negative line. I just want you to explore this kind of ideas, okay? And this would be a negative correlation, so you should be looking for a negative R. Take a look at this one right here. The points are so scattered, I cannot tell you if it's going up, so distinct as this one was, so simple. This one is so scattered all around, there's no way, I'm not sure if I would put a up line or a down line. I really don't know. This is so scattered, there is no correlation at all. Okay, no correlation at all. So I want to pick a R value to best represent no correlation. Would be the R value closest to 0. Okay, closest to 0 as possible. So I have 0.5 and negative 0.5, so that's halfway between 0 and negative 1, and that's halfway between 0 and positive 1. And then I have 0.8, that's way closer to 1 than it is to 0. And then I have 0.01, that is the closest to 0 we have. Okay? So maybe you need to draw a number line so you can see this is 0, this is 1, here is 0.5, and then we try to say, isn't that 0.001, wouldn't it be closer right here than 0.5? So maybe you need to draw a line and play with it, okay? And that is how you finish this whole worksheet. I'm almost all done for you. You can do it. Come and ask me for help. Thank you.